So here we're going to have a look at how to understand graph of a function in a light of calculus derivatives. So let's see. A part of the graph of the function g is shown in the diagram below, and we can see that it looks like a cubic function. Okay, and we have some points. So what do we need to do? Write down two values of x for which derivative of x is equal 0. That's what that description means. When you have that dash here, let's use ordinary words, that means a derivative. So they are saying when value of derivative is 0. So when value of derivative. Now, we don't have the function. We therefore cannot create a derivative. So how are we going to solve it? Well, part of the knowledge that we're going to apply here is that the value of derivative at a specific point will be the same as the slope of, and here either we're going to be looking at tangent with the curve, or basically we are talking slope of a function at that particular point. So value of derivative will be the same as the value of the slope at that point. Okay, so at what places will the slope of this function be 0? When do we have 0 slope? We have 0 slope when we have a horizontal line. So here, this place, I can draw a horizontal line, and here in this place, I can draw a horizontal line. So in the light of calculus, when we have the maximum or the minimum place of the function, that's when that slope is 0. How do I know the maximum or minimum place of the function? In the graph, you can see there are those type of bumps. Let's call that. So that's when I know that's what they are. They are maximum and minimum. And this place is the maximum. So when it is that type of a U shape upside down, that's the maximum. And this place is the minimum. That's the U shape up way. So that's how we know. So in this case, what's the value of x? We are told that here the coordinate, the x coordinate here is 4. So we are saying it is 4. And here we are told that that x coordinate is 10. Therefore, x is 10. Now let's have a look at second part. So is g what? Derivative of g when x is 11, positive or negative? Let's write it down. So what that description mean, we take derivative of g, and we are looking for value of derivative at what point? When x is 11. And again, here the same logic, because we do not have the derivative of the function to create derivative, we are saying we're going to use the knowledge that the value of derivative is the same. Value of derivative is the same as the value of the slope. So basically, I'm saying, is the slope of our function g is going to be positive or negative at x equal 11. Why do we need to specify? Because depending on which point I'm going to do, that's how the slope of this function is going to be. All these places, like here, when the line goes up, all of this one here will have what? Positive slope. Then from this point all the way when it is going down, so all this part of the function will have a negative slope. And then again, when the line goes up, that slope will be positive. So 11 is somewhere here, and we know that at that point the line goes up, therefore it has a positive slope. Therefore, our answer here is that it is positive, and we have to justify our answer. And that's how we justify that at when x is 11, the line of the graph is going up. Therefore, that means that it has a positive slope.